In this video, I'm going to introduce you to regular expressions. Alright, so by now you should be reasonably comfortable with the idea of regular languages and finite state machines. And particularly for this video, if you're not fairly comfortable with the idea of a union of two languages, the concatenation of languages, and the clean star or clean plus of a language, then I'd go back over your previous notes. If I would expect any part of this course to be known by a student before they started, it would be the regex, which is short for regular expressions. They are a way of describing patterns that are very common in the software engineering and computer science fields, and they can be found from text editors to search and replace utilities to Unix tools such as sed and grep, and they're even built into some languages such as Perl and JavaScript, whilst many of the major languages like Python, Java and C++ supply them via a standard library. What you can see in the middle of your screen here is a fairly simple regular expression that uses most of the elements that I'm going to describe in this video. So by the end of this video, you should be able to read and understand what that is, be able to turn that into a description of the language in English, and be able to build a finite state machine for it. So, in this video I'm going to present 8 rules to what a regex is. The first 3 of these rules are our base building blocks, and that from these we can build up the remainder of our regexes. And the final 5 rules are the operators that we'll use to build more and more complicated regular expressions. The first rule is simple. The empty set is a regular expression. So the regular expression, when we write down the empty set, describes a language which is simply the empty set. Epsilon is a regular expression, and when we write it down as such, it represents the language which consists only of the empty string. And you can see how that is different to the previous language. Every element in the alphabet, sigma, is a regular expression. So, if sigma consists of A and B, then A written down is a regular expression which refers to the language that consists only of an A, and B is similarly. It is the language that consists only of a B. Forgive my poor braces. So, we have the starting building blocks. We can describe a language consisting of the empty string, a language which has no elements, and a language which consists of strings made up of single symbols from our alphabet. So, rule 4. If we have a regular expression alpha, and that can be anything that satisfies the rules for a regular expression, and a similar one beta, then alpha beta is a regular expression. And when it's written down, it refers to the language built by concatenating the language alpha, the language described by the regular expression alpha, concatenated with the language described by the regular expression beta. So for instance, if we had an A and we had a B as 2 regexes, their respective languages are the set of just an A and the set of just a B, then AB together as a regex refers to the language built by concatenating those 2 languages, which you should remember from your first few weeks is simply the language with only the string AB in it. It gets more complicated with more complicated regular expressions, obviously. Similarly, if we have 2 regular expressions alpha and beta, then the regular expression alpha union beta is also a regex. So, by the same meaning, if we had the regex A and the regex B, each referring to their previous languages, then the regex A union B refers to the language built by getting the union of the 2 original languages. In this case, that is the language which has an A as one of its member strings and B as one of its member strings. Rule 6. If we have a regular expression alpha, then alpha clean star is also a regular expression. So, let's say we have the regex A, which describes the language consisting only of one string made up of one A. Then, A clean is a regex, which refers to the language built up by taking the clean star of the language represented by the regex A, which is the clean star of this set, which we know contains the empty string, 1A, 2A's, and so on ad infinitum. Alright, we're almost there. Rule 7. If we have a regular expression alpha, then alpha clean plus is also a regular expression. And this is pretty simple given our previous rule, because the only difference with this one is we don't include the empty string. So before, where we ended up with a set of strings that included the empty string and any number of A's of any length, when we have a clean plus, then we don't get the empty string. Nice and simple. Alright, final rule. If we have a regular expression alpha, then that regular expression in brackets is also a regular expression. This doesn't add us anything extra, it just gives us a nice way to group things together. So, when we have a set of parentheses with a regex in them, the language described by that regex is no different than the original regular expression. So for instance, where we had A as a regular expression which described the language that had just one string with one A, then this regular expression describes the exact same language. However, it is useful for when we have to later on define an order of operations of our regular expressions. This will help us, just like with basic mathematics with pluses and minuses and then brackets taking over. This will help us deal with things where we want lower order operators to take precedence. Alright, so I promised you would be able to understand what this regex is. So, we can see that it is the language made up by first starting with an A, and that just represents the language consisting of one A, that cleaned, concatenated with a B, and another B, and an A, nothing complicated here. So we can have any number of A's followed by B, B, A, then one or more occurrences, because this parenthesis groups this, and we have a clean plus, so that says one or more, that's not allowed to contain the empty string. So one or more occurrences of any number of BA or AB or epsilon. Now, because I've included epsilon in here, this one is no different to just saying BA or AB clean star. So, can you see how you would be able to describe the language given by an arbitrary regular expression? And, now knowing that language, be able to build a finite state machine capable of accepting it. So, from this video, you should understand the basics of what a regular expression is and how to parse one. That is, how to read one and understand what's going on. So, for more information, you can see the entire chapter in Elaine Rich's textbook that's on regular expressions, chapter 6, and I'll see you in the next video.